For first order reactions, if a reaction is overall first order, then you know that rate would be equal to K times the concentration of a single reactant, right? Because if it's overall first order, it might have more than one reactant, but it's going to be first order for one of those and zero order for the other one. We've also looked at equations that say that the rate is equal to the change in concentration divided by the change in time. Okay, so we can take all that and put all those formulas together and do some calculus integration. And lucky for us, we don't have to worry about how to do the integration. We just have a formula. For a first order overall reaction, we have this formula. The ln of A sub T is equal to negative KT plus the ln of A sub 0. And I'm going to tell you what all that means. First of all, what does the ln mean? Ln is natural log. Okay, just a function on your calculator. It's the natural log. Not log, it's going to be ln. Y'all know that square brackets around A means concentration of A, and A would be whatever component you're talking about in that reaction. Okay, the A, of course, is just a generic designation. But A, there's an AT and there's an A0. Both of those mean concentration, but the A0, y'all, that's talking about at 0 time. In other words, that's the initial, yes. The initial concentration of that component. And AT is the concentration of that component at some point in time. So realize that the 0 and the T, those are designations, like M1V1 equals M2V2. The little ones and twos are just designations. Those are not mathematical operations. What is K? K is still that rate constant like we've been looking at. What is T? T is time. And so we're going to work a problem using this formula because I find that students struggle, they get tripped up on the math and just the basic algebra of the formula. One thing I want to point out to you, what kind of units would a first order rate constant have? If it's a first order rate constant, it's going to be time to the -1, right? And time could be whatever, seconds, minutes, hours, days, years. Then you're going to have to multiply that value of K times some time. They've got to be in the same type of units, right? You can't take a rate constant that's in an S-1 and multiply it by a time that's in minutes. And y'all know that, but I just want to point it out to you because that's what this first problem is going to do. So here's the problem. The reaction of cisplatin and cisplatin is a chemotherapy drug at 37 degrees Celsius has a rate constant equal to 1.87 times 10 to the -3 minute to the -1. Suppose the concentration of cisplatin in the bloodstream of a patient is 4.73 times 10 to the minus 4 molar. Bless you. What will the concentration be after 24 hours? Okay, guys, obviously, I'm going to use this formula that I just gave you. But that formula, that natural log formula, that is specific for a first order overall reaction. If a reaction is second order, you cannot use that formula. There's a different one I'm going to give you in a minute. Okay, so right now it's easy. We know it's that formula because we don't have the other one yet, because that's what we're talking about. But do you guys see what in that problem would clue you in to first order? The units of the rate constant. The MIN minus 1 tells me, oh, that's first order, without it being said. So you guys plug those numbers into the equation. So y'all are entering the numbers on the right in your calculator, and I'm getting that the natural log of x, and x is my concentration at some point in time, is negative, my calculator says 10.3492, et cetera, et cetera, et cetera, et cetera. Okay? Are y'all getting to that answer? Guys, the natural log of x is equal to negative 10.34. But the question wants to know, what is x? What is the concentration? How do you get rid of the natural log? You have to do second ln on your calculator. You're looking for that little e to the x button on your calculator. So the second ln gets rid of the natural log on that side. So you got to take the second ln of that negative 10.34 or whatever. And you should get 3.20 times 10 to the minus 5 molar. That is the correct answer to the question. That's the final answer. Go ahead.
Hey, what's up, Kurt? Miss you.
That's funny. So here's another one using the first order formula. Okay, we know our formula. We can tell from the problem easily what K is, because it's that 3.43 times 10 to the minus 2 per second. Oh, there's a negative here. I'm making that red because I forgot the negative, so now it's blurring with the equals.
We just make up our initial concentration.
Yes. T is what we're solving for. You're not given a concentration, so like Andy said, can't you just make up an initial concentration? What number are you going to use?
15.
That's what I would use.
10.
If your initial concentration is 10, then what's your concentration going to be? 1, because it's going to go to 1/10 that. So that's really easy. Just start with 10 for an initial concentration and end with 1. Do y'all see how we did that? You should get 67.1 seconds. Make sure everybody gets to that answer.